Hello, it's What the Doodle here. In today's session, we're going to have a look at creating a toy HTML builder in Rust. But let's take a step back. What is HTML? Well, in essence, it's just a thing that is a list of things. And those things may or may not be surrounded by tags. Of course, this makes HTML a recursive structure, because those things themselves could be a HTML thing that contains a list of things that may or may not be surrounded by tags. So much like turtles all the way down, it's tags all the way down. Okay, why would you want to create a nestable builder like this? Well, an infinitely nestable builder allows one to programmatically generate some output in a typesafe and precise way. It is also the base level building block for layering higher levels of abstractions on top of the builder. For example, one could create functions that emit a particular component, and those components could of course be nested and composable. Or another example could be creating a data adapter that takes data in one particular format and then uses the nestable builder to transform it to its final target format. Okay, let's get cracking. So the first thing, let's boot up a terminal, and let's make the screen a little bit larger so you guys can follow along. And I'll go into the desktop and clear the desktop, and of course all of this code will be available on my GitHub profile, so that you can have a look at that code if you want to. We're going to use cargo new in order to create a new Rust project, so we shall call this toy HTML builder. Okay, let's get into that directory, and we will boot up Visual Studio Code. We don't need the terminal, we can close that for now. So let's have a look. This will just be the skeleton code that's just been created by the cargo new command. We could open up the little terminal inside of Visual Studio Code. Let's just expand that a little bit. Okay, let's clear that little terminal and just do cargo run just to make sure it compiles. And yep, that's fine. Okay, so we need to define a few structures. So let's do the HTML, which is the top level. And as we mentioned, all that is just a set of things. And we can model that using a vector. Internal, we need to call the internal thing something. So for now, I'll just call that node. And now we can define the node structure. And that's pretty simple because essentially it's some kind of text. Let's just model that as a string, and then a tag as well associated with that, which may be empty, but again we can model that as a string, so that's fine. So we've got our HTML, which is a set of things, and that node, if you like, is a string or a tag. And now we can actually implement the actual HTML. Now we will need a sort of a way to initialize the HTML structure, so we can just use the idiom of calling it a new, and it will return a self. And it's very easy to initialize that because it's just an empty array essentially. So we can say something like the items is just essentially a new vector. So also, in addition to defining the way to initialize that HTML structure, we need a way to add nodes, if you like, to that list. So that's pretty straightforward as well. So let's call it add. We pass the self and the node, which is of type node, and that will return itself. And what we'll do is we'll just simply say self.items.push, and we're going to push the node in and then return the self. So that's fine. Now we've implemented a way to initialize it and a way to add some nodes into the HTML itself. And if we just do cargo run just to see if that compiles, that's fine. And we can do a little bit of formatting as well. Just usually good to format things. Okay, that's fine. Now this is all fine. That's not a problem. And we could probably build some sort of in terms of the implementation, we could add another definition in order to render out that HTML. However, the only thing is as we mentioned, because it's sort of that recursive nature, it would be nice for this text to be able to essentially not just be a text type, but also take, for example, HTML. So instead of just passing a string, it'd be nice to basically to be able to take both. Now we can do that if we start using generic. So if this is a generic type, of course, then in that case we need to parameterize that node structure with a generic type variable, if you like. And of course that won't compile because it'll break, so that we can see that breaking. So yes, it will say, well, because that's not there, so you need to kind of define it everywhere, but that's fine. That's the benefit of having a compiled language, is because it will essentially spell out to you exactly where you need it. So of course we would need to create that generic over here, which probably means that we'd need to pass that down from the top level as well. And where else would we need it? We'd probably need it here as well. So let's do that. So essentially we have the top level, we have a generic type parameter, and we pass that down into the node, and we pass it into the node itself and there, and also we pass it here. So does this compile now? Let's just check. Okay, we probably missed something somewhere. Let's have a look. Missing generic argument type. Okay, yes, we missed it here in the actual implementation. The type parameter was missing it, so now if we do it again, no, wherever we missed it, okay, yep, in the actual implementation, we need to put it there as well. Let's see if it compiles now. Yes, brilliant. So we've done a quick little refactoring, and essentially we are passing a generic type parameter so that this text thing, text field, if you like, could be essentially a string, or it could be a HTML element. Now, in order to do that, what we'll do is we'll create a trait definition, and we'll call it something like toText. And all this trait will require as a sort of a contract, if you like, is to have some kind of function. Let's call this toText, and essentially all that will do is just provide us with a string, really. Now we can implement this particular trait, but before we do that, what we'll do is we will actually start doing some trait bounds, because we don't want this generic type to be basically anything. We want it specifically to be of this kind of this trait, essentially. So to do that, let's have a look. We will go to here, for example, and we will say that this will take the toText trait, so it's bound, essentially. That type parameter is bound, essentially. It's kind of limited. So it essentially means it'll take any kind of generic type as long as it implements the toText trait, essentially. That's what we're saying. And of course we'd need that here as well. So let's add that there, and let's see if that compiles. So probably missing yes on the implementation as well. So we need to add that trait generic bound, if you like, here as well. Let's see if it runs. So fine. So now we have that. That's fine. And so now we just need to essentially implement it, really. Now, the only two implementations we really care about are strings, as we mentioned earlier, because we wanted this field to be either of type string or type HTML. So really that's all we need to do. Let me just move that down a little bit. Okay, so to implement, say for example, implement the trait for string, we just say toText for string. So essentially we're saying that we need to have the toText function of that trait, and I'll take a self and return a string. And I mean, the string type is just easy because it's just, we can do something like this. And if we run that, does that build? Yeah, that does build. Okay. And really the meat of it, or I guess the only really complexity, is to implement the toText for the for HTML. And obviously we need the toText, and that's going to take us off and give us back a string. Okay, so we need to actually implement this for the HTML. So this is the toText trait. Well, let's just create a local mutable variable called HTML, and that's just a string. Because what we'll do is we'll just concatenate and build it up, and essentially we can iterate over the items. And what we can do is we can just check if the if the tag is empty, you can just you can just push that string as is. So what we can do is we can push the text, but we can call the toText because that's the sort of the method, if you like, that's implemented generically, or the trait, or that the actual function within that trait that is implemented for both the text, so the string type as well as the HTML type. So this will be different depending on the actual type that's passed in here. So of course, if the tag is not empty, then we want to actually push something different. In this case, we'll use the format, and what we'll do so what we'll do essentially is if you think about, as we mentioned, HTML is just wrapped around in tags. So we have the actual tag, we then have the actual text, and finally we close that tag, and that is essentially it. So we can then just say that the tag is e.tag and the text is e.text, but toText, which is that trait that we've added. And then finally, of course, we just have to return that. Now, does that compile? So that's a typo. Yes, I was just missing the function, so there's balk syntax. So let's see if that now works. Yep, so I've missed a little equals here. Let's see if that now compiles, and it does. Fantastic. So that is essentially the entire. Well, let's clean that up, the actual formatting. So cargo format. Okay, so everything's now been nicely formatted by cargo, and if I just shunt that across here, and we can expand that over a little bit here. So essentially, yeah, all of the actual implementation is now done. We've got the high-level structures, and it's generic and well parameterized with a type variable, which is the actual string type or the HTML type that can be passed into it. So therefore, that allows this whole thing to be infinitely nested, and then we also have the ability for it to render that using the toText type, which is implemented, if you like, for the HTML as well as for string. So that essentially means we can actually now use this. We can use this implementation. So let's say let HTML equals to HTML new, and we're going to add into that a node, or our first top level, our parent node, if you like, and that's going to contain some text. We'll come back to that in a second, and the tag for that is UL, which is like a user list, for example. Now we can nest this because we can say that actually is HTML new and we can start adding. We can add those nested structures. So for example, in here that would be the text. We could say something like coffee. The tag for that, for example, would be li, and of course, so that's added there. And let's just move that over here. We can now repeat this because we can have multiple of those elements. Let's just do 4 for now. So as you can see, we've got the parent node, if you like, and then inside the parent node, which is of tag ul, and inside that parent tag we've got a nested, the actual text that we nest it with HTML again. We initialize it, and then we just essentially just keep adding a bunch of list items which are sort of nested inside of it. So we could have tea, coffee, maybe milk, and just water as an example. So we've got that, and let's have a look. Yeah, we probably need a semicolon at the end of that, and then finally we can print that whole thing. So we could just say HTML to text, which is the trait that that we implemented. So let's see if that actually well, let's see if we can format this, and if we've actually got, if the thing compiles. So I probably missed something. So it's saying I'm missing a semicolon here. Where is that? Line 22. Okay, let's put line 22. I haven't saved it, that's why. Okay, let's see if we can run the format again. So now it's formatted, and that's probably a good sign. So let's see if we can run it. Okay, so yeah, because these things have to be a string type, so that's fine. What we'll do is because otherwise these would just be sort of slices and things. Okay, let's turn these into proper string types for all of them. Let's see if that now runs. Fantastic, and that's it. That really is. And let's make this as big as I can. So there is the actual output. So we can see that we've got the parent, which is the ul tag, and inside of that we have nested multiple elements and HTML elements of li, and yeah, inside of those are the actual text itself. So that's yeah, this is infinitely nestable because of course each of these text elements you could have yet another HTML, just another HTML structure, and so on, and you could keep on nesting it as deeply as you want. And of course each of these HTML element you can infinitely add more and more nodes, if you like, to them, because they're just HTML, as we said at the beginning, it's just a series of things that may or may not have a markup to them. And yeah, because it represents the same, in theory at least, although this is a very toy example, but obviously you could add all kinds of extra nice things. For example, these tags, you could use enums, for example, so that you don't have to just pass raw strings, and it would be fully type safe, because then you can define all of the universal element types essentially. But yeah, that is essentially it. A completely sort of a HTML builder that is completely infinitely nestable, and yeah, it is obviously an exceptionally toy project. It's not anything serious. So as mentioned, all of this is available on my GitHub, and I'll put a link up so you can have a look for yourself and go through the code. So until next time, I'll see you on the next one.